Okay, so today we are going to talk about computer networks, and as you are or as you all know, computer networks is one big part of our lives nowadays. Or our devices are connected one way or another to a network. For instance, your mobile phone is connected to at least two networks at one time, which is the Wi-Fi and the communication cells through 4G or 3G or 5G, and laptops and computers are connected to the network either by cable or by Wi-Fi. So over here we want to discuss what do we mean by computer networks, and what are the types of computer networks, and what do we mean by an IP address, and how do we set an IP address for a network during the remaining 2 weeks of this semester. So a computer network connects two or more computers autonomously. So I'm here connected to a network, but I don't know who are the other computers on my network. So this is my office over here, and there are multiple computers, including a printer, connected to this network. Now, how do these devices connected? What is the device that connects them? We are going to talk about all of these things. So the computers can be geographically located almost anywhere. Some networks, you think like a building, like our engineering building in the campus. It has, I think, around 400 computers. We have a small server room, but this server room will contain only the switch that connects all these computers. Then there is a wire connecting us to another switch, which is inside building 21, and from there we go out to the internet or to the outside world. So it's not like every building will have its own device that connected to the outside world. There is always a path for the data to go through. Now we have three types of computer networks, which are the LAN, MAN, and WAN. LAN is the local area network, such as the network in our building. We can have a computer room or a computer lab considered as a LAN. We can consider a building as a LAN, local area network. Then we have metropolitan area network, which is a network that spans across the city. Yani أي network is within the city is considered a metropolitan network, and this network basically is smaller than the is larger than the local area network and smaller than the wide area network. Now, wide area network. Now, when you read WAN, you always consider W stands for wireless area network, but WAN, W stands for wide area network, such as a country or network. Now, how is the network connected? The network is connected to all the countries through a cable, fiber optic cable that connects all the countries. Now, if this cable is cut, I think there's we can find it on Google for the fiber network cable connecting countries. It's in the sea, it goes inside the sea, and see how the cable goes. The cable will go inside the sea, and as you can see, it is connecting all the countries. Now, when there is sometimes an earthquake or some problem and this cable is cut, some countries will suffer the loss of speed in internet. Now, you will not get totally disconnected, because it's not like you are connected through one point, but you will lose the speed of the network. Now, the applications of networks. Nowadays, everything is connected through a network. You are attending these classes, unfortunately, through the computer, which is connected to internet connection, which is a network. So nowadays, it's used for source sharing, hardware and software. Information sharing, such as easy accessibility for any data and files, like we do on Microsoft Teams. I upload a file for you, and then you can access that file and download it. Search capability, like we just did. Communication as emails and message broadcasts, such as WhatsApp and all of these applications nowadays. Remote computing and distributed processing. The applications of internet nowadays has spread throughout the world. You can have things that are connected immediately to the internet, such as your coffee machine at home, your fridge, and you can have smart homes where everything is connected through what we call Internet of Things. If you search again for Internet of Things, you are going to find this annoying thing. وين راحت search engines. Okay, now I can open. I find here Google. Now we were talking about Internet of Things. Now, on Internet of Things, you will find all the applications. We call it IoT. Now, an Internet of Things, you can have your dishwasher, your oven, security, computer, microwave, I don't know what's that, your watch. Everything is connected to Internet of Things. You can do that while sitting at home in your office. You can switch on the dishwasher or switch on the lights. Power on your car. This is all called Internet of Things, and it is having a lot of applications, as you know. Now, the network topology. What do we mean by network topology? How the network is connected. How the network is connected, and this is very important, because in network topology, you can see that we have the bus topology. The bus topology. Then we have the ring topology, and we have the star topology. We have the extended star topology, and we have the mesh topology. So the network topology defines the way in which computers, printers, and other devices are connected. A network topology describes the layout of the wire and devices, as well as the paths of the data. Now, the bus topology, as you can see here, it's like connecting all these computers, all these devices to one line. This is called bus topology. Now, in the bus topology, there is a very big problem in which if something breaks over here, if there's a break over here in the line, then this part of the network will be separated from this part of the network. This is called the bus topology. It's commonly referred as the linear bus. All the devices on the bus topology are connected by one single cable, which is not good, by the way. Then you have the star and tree topology. This is the very common used architecture. In the building over here, it's like a star topology. You have your computers, your printers, your devices. Nowadays, even the camera system, all of them connected to one device. This is called the switch or router that connects your device. When you are connected at home, you have your router from Omantel or Ooredoo, and all of the devices are connected to that router. That's star topology. Now what happens if your router is turned off? All the devices will be offline. All the devices will be offline. Yes, it's very commonly used. Yes, it has high risk, but it's the easiest one to establish, and it's considered a very good topology. So the star topology is the most commonly used architecture in the Ethernet LANs. When installed, the star topology resembles a spoken of the bicycle wheel. So this is like spokes of the bicycle wheel. If you put a circle over here, it's something like the bicycle wheel. Larger networks use extended star topology, also called the tree topology. Instead of having one node over here and distributing, you will have one node, and this one will be distributing to more, and so on. So it's called the tree topology. When used with network devices that filter frames or packets like bridges, switches, and routers, this topology significantly reduces the traffic on the wire by sending the packets that are only for that destination. Now we have different devices, different computer network devices, which we are going to talk about. So we have something called a router and something called a switch. These are the two things that you know. So when at home and the internet is not working, you will say, okay, let's restart the router. When in the university and my network is not connected, I will ask the technician, please check the switch. So what's the difference between the router and the switch? We are going to talk about that later on. Then we have something called the ring topology. The ring topology, a frame travels around the ring, stopping at each node. If the node wants to transmit data, it adds data as well as the destination address to the frame. Now the difference between the ring topology and the bus topology, الباص كان عبارة الباص كان one line and connected like this. A ring topology, they connected the other two sides together. So if a cut happens over here, this part will be still connected to this part. So a ring topology is most commonly used for connecting wide area, geographically distant places. Use the ring topology. So the frame then continues around the ring until the finds the destination node. طب ايش هو الفريم؟ احنا بنحكي عن الفريم. Frame is basically data as it moves. We call it a packet or a frame. Frame اللي هو الإطار. Okay, a frame is إطار الصورة. You call it a frame. Now, a frame is basically the encapsulation of the data, but it's empty. So you need to put the data inside it. Once the data is there, you can travel with the data inside the frame. The frame then continues around the ring until it finds the destination node, which takes the data out of the frame. في عندنا two types of topologies. في عندنا single ring and the dual ring. All the devices on the network share a single cable اللي هو هذا single ring topology. And a dual ring topology allows data to be sent in both directions. So one data will be sent in this way and one data will be sent in this way. This will significantly reduce the amount of time that the data needs to travel. Then we have the mesh topology. The mesh topology is very expensive. Mesh topology is very reliable. The mesh topology has its own unique applications. As you can see in the mesh topology, each device over here is connected to all the devices. So the mesh topology connects the devices nodes to each other for redundancy and fault tolerance. It is used in WANs and to interconnect LANs for mission critical networks like those used by banks and financial institutions. In military and finance, you cannot have one cable connecting the branch. You cannot depend on one line. So instead, if this line goes dead, no problem. You have another 4 lines connected to it. So the information will reach from somewhere else. So the information can reach this path, or can reach from this path, or can reach from this path, or any other path. But there is no way to depend on one line. Applications over here are vast. Applications such as the banks and the military, they use these sorts of applications. So this topology again is expensive and difficult to implement, but it is worth it if you have the money for it. Now, what are the components of a network? First of all, you have the physical media. The physical media, how am I going to connect to the internet? Option 1 is through cable. Option 2 is through Wi-Fi. Option 3, Bluetooth. Anyone knows any other options to connect to the internet? Anyone knows? What is option 4? How can I connect to the network? Through GSM. Option 5. Come on, think.
LAN.
LAN is through cable. Satellite. You heard about internet satellite or satellite internet? A satellite internet is it's not allowed, by the way, but you know SpaceX, Elon Musk, you know Tesla. ولا ما سمعتوا فيهم؟ شوفوا الساتلايت انترنت. يس هاي فتحنا على اريد على طول. ساتلايت هوم انترنت. Let me find you images. A satellite internet, you are going to have something like your satellite for the TV, but you are going to stream data. Instead of streaming TV channels, you are going to stream data. Now there is SpaceX Starlink, this one. SpaceX Starlink is a very ambitious طموح على الخطة إنهم they want to cover the whole world with satellites. I think 3,000 or 4,000 satellites, okay, something like this. And then you can buy basically a small satellite receiver, this one. And if you check for videos, there is videos how it will connect to the nearest satellite, and then you can use the internet. This is the satellite home internet, a part of initiative to regulatory authority. Local internet speed 6 megabytes, 15 months. Okay, so there is where you connect to the network. Now, يعني, there is a lot of things involved when we talk about satellite internet, because there is no control on what you can access, and so it's not that advisable. But the idea was for rural areas, المناطق النائية, where there is no cell coverage, they use this option, which is the satellite internet. Now, these are different types of connecting medias. Then we have the interconnecting devices. How do I connect here? Through the RJ45 cable here through the Wi-Fi modem, Bluetooth modem, GSM modem, and the satellite modem. All of these, they have different connecting devices. Then you have your computer. After that, you need some network software that will allow the packets to be sent and received. These softwares, such as the TCP/IP, use TCP/IP protocols to send and receive data. And finally, you need your application, such as WhatsApp or whatever device you are, or whatever application you are using. Now, in network media, there is in the practical component, I put lab. Usually in the lab, you will go down and you will learn how to connect the network cables. If you ever seen a network cable is basically one cable that has 8 different wires. These wires are twisted pairs. Twisting in the wires is there to remove the electromagnetic interference. So the network media can be defined as simply as the means on which the data are sent from one computer to another, either by cable or by wireless means. There is a full lab. If you open the practical component, and Ms. Alia will cover it with you, you will talk on the how the network cable is done and how you can do it. Then we have the networking devices. في عنا إشي اسمه الهب, switches, routers, wireless access points, and modems. Now, at home, you use a router. In the university, we use a switch. I think, let me check. I have a switch over here. I hope you can see this. هذا switch. Okay. This switch will take cable from back, power, and it has ports. هلا هدول ports you connect them to the devices that you want to connect, say computers, printers, whatever. And then these switches will be then connected to a router. The switch will never take you outside the network. Yani you cannot connect to the internet using a switch. You connect to the internet using a router. That's why at home you have a router. You don't have a switch. But you may have a switch. إمتى؟ إذا كان عندك router. By the way, router شكله هيك. This is the symbol of a router. It's a circle with an X inside. So if you have a router, and your router has maybe one output port, then you can connect it to a switch, and the switch also may have wireless communication and ports, and you can extend your network. Like at my home, I'm having a router, but the router signal does not reach to the end of the house. So what I did, there's two options. Either you buy a network extender, in which it is basically a hub or a repeater that will repeat the signal only, or I just did what I took a wire line out of the router and send it from the window outside to the other rooms and put a wireless switch over there that will connect the other devices. This is a more practical and more better solution for your network problems. So you may have hubs, switches, routers, wireless access points. The wireless access points, when you are moving inside the university, you see these wireless network devices, and as you move, you are still connected to the internet through the same username and password. You don't have to change your username and password because you are using wireless access points, and of course you have also the modems as an option. Then you have the computers, which are clients and servers. All the computers over here in the, let's say, computer labs are considered a client, and then you have a server room. In the university we have one big server room in building 21, and this server room will help in storing the data and managing the connections between the devices. So in a client server network, the network services are located in the dedicated computer whose only function is to respond to requests of clients. Sometimes you can do operations on the server itself if there is a very big computation which is needed, and other times nowadays it's not that much because our computers are getting faster and better. Now, network communication. In order to communicate, we need to recognize the data. We need to divide the data into manageable chunks. إيش يعني? If I want to send a video which is around 2 megabytes, it will not send 2 megabytes. You need to divide the data into manageable chunks. بتقطعه. Okay? Then add information to each chunk. قطعت الفيديو maybe to 500 bytes chunks. ببداية وبالآخر I will add information. Who's the source and where is the destination, where I am going to send it. Then determine the data, where the data is coming from, and identify where the data is going to. This is added to the chunk of information. Then we add timing error. طبعا when we are sending data, we basically put a timestamp on the data. الهدف من timestamp on the data is basically to see how long it took the packet to travel. Now the packet له time. After that time it will be considered as lost and it will be resent again. So this is very important to add a timestamp to the packet and then put the data on the network and send it away. We need some sort of methods to standardize how data is sent and received. So we have the standard protocols needed. These standard protocols, which are the network operating systems, that strict rules which are called protocols on how data is sent and received. We have different types of protocols. We are going to talk about a few of these protocols that are very important when sending and receiving data. We need the need for standard protocols so that software and hardware from different vendors could communicate easily. مش معقول I get a computer, let's say from China, and then when I come to Oman to start it, it will not work on the wireless connection because it's using a different wireless frequency. Wireless frequencies are standard. The network cables are standard. Bluetooth is standard. Everything has a standard which connects it. Now the organizations that govern these standards are the American National Standards Institute. You may hear about it or not. Then you have the Electronic Industrial Alliance, and then there is the IEEE, Electrical and Electronic Engineers. Mostly we are considered with the IEEE because it's the International Society of Engineers Professionals that promote the development and education in engineering and computer science. Anything related to engineering and computer science is basically done through IEEE and through their operations. The ISO, International Organization for Standards. The ISO basically has the standards for everything. And when we talk about standards, if I go to China and go to a company and tell them that I want to build, you want to manufacture a meter for me, a measuring meter, and I want to tell the guy, okay, let's cut some corners and make my meter 95 centimeters. So the 95 centimeters, I will divide them into 100 parts, label them, and consider them as a meter. Without a standardization, then things will go out of hand. So the ISO, they have a standard for meter, they have a standard for kilogram, they have a standard for everything, in which they measure everything against it. So it's very important to have these standards. So the ISO is the organization that is a collection of from 130 countries. It's established international technological standards to facilitate the global exchange of data. Then they have the International Telecommunication Union, which is the agency to regulate the international telecommunication and radio and TVs. We are not considered much about this. In networks, we have two main standards, which is the OSI and the 802 model. Now, if you go and to the internet once more and you want to talk about Wi-Fi standards, when you talk about Wi-Fi standards, you always see 802.11, 802.11b, D, G, and so on. So 802 is a very common number in networks. So these standards define the rules for how the network devices communicate, the methods used to determine when to send data, the methods to ensure that the data is sent and received correctly, how the network is cabled, how the network is maintained, and how the data is flowing, and the number of bits and their representation. The Open System Interconnection OSI اللي هم من 1977-1978 is the International Organization of Standards من ISO, began developing specifications for the networks. As we said earlier, we have the ISO and we have the IEEE. Now the ISO started with the Open System Interconnection OSI, and the OSI model, which we are going to talk about later on, was released. It's an international standard best known for its guiding and understanding of network communication. فاحنا لما نيجي نحكي على النتورك, we always talk about the OSI model, which is from the ISO. Okay, it's funny how this is open standard network, and there is the ISO, which is the ISO, and OSI, which is the open standard network, the opposite letters. بعدين in February 1980, that's why 802, they started a project, IEEE started a project for standardizing the networks. So this is February 1980, so that's why it's 802. It predates the OSI standards, but developed in cooperation with OSI, defines the aspects of networking related to physical cabling, connectivity, error checking, transmitting, encryption, and emerging technologies. So everything related to networking later on came under the 802 model. So next time we will be talking about the 7 layers of the open system interconnection model, or the OSI model. This model explains how the network is built in a computer system and how we are going to deal with it.